for this next lecture of theory and analysis of composite material. So, as per the content of the syllabus, as per the course content in the section first chapter, Introduction to Composite Material. So, during last lecture, we started with this chapter. We have seen the definition of composite material, then classification based on the matrix material and classification based on the reinforcement material. So inside this definition and classification, afterwards we have seen the types of matrix material. So we have seen that broadly the matrix material are of three kinds, out of which first one is the polymer matrix, second one is the metal matrix, and third one is the ceramic matrix composites. Then in case of reinforcements, again we are trying to go in detail for this reinforcement. We were in the discussion. So this figure here you can observe. So inside this metal matrix composites and ceramic matrix composites, and by two ceramic and metals. Suppose this particular figure is self. We can consider this as the self-explanatory figure. Because this hatching line portion which is shown here, that represents the ceramic, then the portion which is shown here with dark surface, that is composite, and whatever the surface is present here with faint space shown here, so that is the metal. As far as concerned with the ceramics, so here we can say that the strength of the ceramic is very good, or very as compared to these two materials, composite as well as metal. As compared to metal, ceramic has large strength. So that's why on this vertical end, if we consider this as one end of this this parameter, then strength is regarded as one of the important parameter, and this is high in case of ceramic. If we consider the second parameter as the affordability, then metals are more affordable than ceramic. So why they are affordable? Because we know that the processing of this metal is quite easy as compared to ceramics. Then most probably the metals are used for different applications. So affordability of this metal is large as compared to the ceramic. As far as concerned with corrosion resistance, ceramic has somewhat large corrosion resistance as compared to few of the metals. Few metals corrodes earlier. Few of the metals are there that have good corrosion resistance, but ceramic has good corrosion resistance as compared to metals. Here we can see. As far as concerned with the joinability, all of we know that metals have good capacity to join. So join ability in case of metal is large as compared to the ceramics. As far as concerned with the formability, metals have good formability as compared to ceramics. So ceramics are stronger in strength, but in all strength and corrosion resistance. So ceramics are strong in strength and corrosion resistance, but affordability, joinability, formability, toughness, in all these parameters, this ceramic are weaker element. If we consider the metal, then metals are not that much strong as compared to ceramic. Ceramic has a large strength as compared to metal, but affordability is quite good, corrosion is moderate, corrosion resistance is moderate, joinability is good, formability is good, and toughness is also good in case of these metals. Is it okay? So here our interest is to observe the composite, because naturally available ceramic and naturally available metals, how they are compared. So the comparative parameters, the parameters with which they are compared, that are shown here. Each and every line represents the property of the ceramic and metal. But if we are manufacturing any composite material which consists of metal matrix and ceramic reinforcement, if suppose ceramic is reinforced inside the metal, then what we are getting, so that is shown here with this, we can say this as the dark portion which is shifted in at the center, at the core of this total figure. So here you can observe that this core portion it is shown here, which is darkened portion here. This is the properties of the composite material. So what is in composite material? So in case of composite material, strength is moderate. So it is more than metal. So by adding ceramic inside the metal, we can improve the strength of the metal. That is the one advantage we are getting as a composite material. So here it is not strong enough up to the ceramic, but it is not weak up to the metal also. It is intermediate of that, moderate of that. And that's why this particular line which is shown here, so this shows that the toughness of the composite material is quite, strength of the composite material is quite good than metal. As far as concerned with affordability, metals are more affordable than ceramic, but composites are not affordable because this becomes very complicated for manufacturing of the composite material. Because for metal, the processes are set. Whatever the processes present inside the metallurgy, all these processes we can directly apply for the metals. For ceramic, it is somewhat difficult because of its high processing temperature, but composite material is difficult for the processing, and that's why affordability is also less in case of composite material. Corrosion resistance is also lesser in case of composite material. Is it okay? So we are considering metal matrix composite, metal matrix ceramic reinforced composite. That's why we are saying corrosion resistance is less. Otherwise, if that material is polymer matrix composite, then its corrosion resistance will be high. If suppose that is ceramic matrix reinforcement, then its corrosion resistance will be high. But for metal matrix and ceramic reinforced composite, corrosion resistance is very low. Is it okay? Then joinability of the composite material is also one kind of drawback in case of composite, because in case of metals, what joinability is good, but composites are not that much good enough to join with each other. Formability is also weak point of this composite material, and toughness is also comparatively weak, because toughness of this ceramic is very low as compared to metal, but for composite it becomes intermediate of the metal and ceramic. So strong strength is more than metal, and toughness is more than ceramic. That kind of materials get manufactured with metal matrix composite and ceramic reinforced composite material. Is it okay? So yesterday we were discussing about the first of all fundamental things of the composite materials, and inside that we have seen that what is the composite material. So classification of the composite material, and then now we have seen one of the case study. Suppose different fibers are present here. We are coming to the new point, that is definition, classification, type of matrix material, and reinforcements. So let us first of all come to the reinforcement material. So for that purpose, we are going to use this book of Jones. So here also you can see that brief of this materials has been given, that when to use the composite material, what is the composite material, that is shown in this first page. That is properties that can be improved by forming composite material. Inside that it is these are enlisted here: strength, stiffness, corrosion resistance, wear resistance. Strength, stiffness, corrosion resistance, wear resistance, attractiveness, weight, fatigue life, temperature, thermal insulation, thermal conductivity, and acoustic insulation. See here, as per the requirement of the material, if strength is the requirement, then accordingly matter will be designed. Stiffness, corrosion resistance. So if my interest is to manufacture the material which has good corrosion resistance, then my parameters will be different. But I can manufacture any composite material which has better properties in the corrosion resistance as compared to conventional metals. Is it okay? So that is the beauty of the composite material. As far as concerned with the classification and characteristics of the composite material, so let us come to the reinforcement part, because in case of matrix part we have seen that polymer matrix composite, metal matrix composite, and ceramic matrix composite. So these are the three types of composite material based on matrix. But as far as concerned with the ceramic reinforcement, now here you can see, here you can observe that classification and characteristics of composite material. Here you can see the classification and characteristics of composite material. So for commonly accepted type of composite materials, first of all, fiber composite material that consists of fiber in a matrix. Yesterday we were discussing about the based on the reinforcement size, and based on reinforcement size we have seen that particulate reinforcement, short fiber reinforcement, viscous long fiber type of reinforcement, monofilament type of reinforcement, then laminated type. So likewise here also fibrous composites. So fibrous composites materials means that consists of fibers, maybe carbon fiber, glass fiber, etc. inside the matrix, and matrix may be polymer. In case of laminated composite materials, now we will observe what is laminated, laminas, one over the another. So one is the lamina, another is the lamina. Like this, laminated, one over the another. Like this, if the structure is present, then that is considered to be laminated composite material, and that consists of layers of various materials. One layer of matrix, another of reinforcement. Like these alternative layers are there. Particulate composite materials that are composed of particles in a matrix. So small particles which are embedded inside the matrix, and that form the particulate reinforced metal matrix composites. Then combinations of some of all of the first three types may be possible. That is, fibers composites, laminated composites, or fiber and particulate composite, or laminated and particulate composite. Like this combination is also possible here. Is it okay? Now here you can see that if we take the example of this fiber reinforced composite, then already now first of all go with this small figures, we can try to understand that how this we are separating the different reinforcement. Is it okay? See, in case of particles, small particles are there. In case of fibers, small fibers are there. Is it okay? So let us see first of all small figures. That figures are, I think, on next page, so that we will see later on. Let us come to the fibrous composite. So as already we are discussing about this fibers, so most probably the word fiber is used in case of two terminologies or two type of materials, out of which one is the carbon fiber and second one is the glass fiber. Is it okay? So long fiber is various forms and are inherently made stiff and stronger than the same material in the bulk form. So suppose any plate of glass fracture or stresses is only there, few thousand pounds, suppose small are there, then that fibers one or another we can pack, and in between we can use the different matrix material. Suppose epoxy is used in between two layers of carbon fiber, then carbon fiber reinforced epoxy composites. If suppose glass fiber is used in between two epoxies there, suppose you do layer of epoxy, then layer of carbon fiber, then again layer of epoxy, like this structure is there. So that is fiber reinforced. In that case, the fiber is characterized geometrically, but very high length to diameter ratio. So here we can see example of this. Here in cow, this example is given. You can observe the screen is present in front of you. Graphite fiber. If suppose graphite fiber, then what is the specific gravity of the graphite fiber? That is 1.8. Specific gravity Here you may consider this specific in case of both the units, that suppose we are referring here it as SI unit. Then in case of SI unit, graphite fiber, normally what is the Young's modulus of graphite fiber? So that is 230 gigapascal. Is it okay? See, it is not less, very large. 230 gigapascal is the Young's modulus of this graphite fiber. See, aramide fiber 124, glass fiber 85, unidirectional graphite epoxy, that is 181. Then unidirectional glass epoxy, that is 838. So here you can see that exactly what is the concept of the fiber, and then after reinforcing that fiber inside the matrix material, how different properties we are getting here. For Young's modulus, for ultimate strength, okay, so ultimate strength in case of we may consider the tensile strength, ultimate tensile strength. In case of graphite fiber, you can observe here that 2067 megapascal. For aramide fiber, it is 1379. So for graphite fiber, how it is so large? So you can observe here. If we compare these materials with our steel or aluminum material, then you will be able to difference between them. Suppose I am comparing aluminum with graphite fiber. So for aluminum, specific gravity, we may consider for our sake of simplicity it as suppose density. Is it okay? So for aluminum, density is 2.6. For iron, the density is 7.8. But in case of graphite fiber, that is 1.8. For aramide fiber, that is 1.4. Glass fiber, that is again 2.5. So here you can see that how smaller the specific gravity or the densities of these materials are there. And then for aluminum, generally Young's modulus is near about in the range of 70 gigapascal. Is it okay? So Young's modulus in case of aluminum near about 70. In case of steel, that is 3 times larger than aluminum, that is near about 206, more than 200, 210. Like this, 3 times near about Young's modulus is present in case of iron, steel. So that is 3 times of aluminum, but in gigapascal. So E 70 or 200 gigapascal in case of aluminum or steel. Now we are going to compare that with glass fiber. So for glass fiber, it is again more than steel. So for steel, it is 200, 210, but in case of glass fiber, that is 230. How large these graphite fibers are there? And for glass fiber, it is 85, or for aramide fiber, it is 124. So as far as concerned with the combination of that, if composite material is manufactured, then if graphite epoxy, that kind of composite has been manufactured, we will get the density as 1.6. If suppose glass epoxy you are going to manufacture, then we will get this as 1.8. So specific gravity or density of these materials are very small. Here you can see that 7.8 for steel, 7.8, and for the composite of graphite epoxy, that is 1.6. For glass epoxy, that is 1.8. Means we may say that steel material is near about 5 times the graphite epoxy in weight. Okay, steel material is near about 5 times that weight of the steel material is 5 times than that of graphite epoxy, near about 4.5 times, that is glass epoxy. So that is so large, is it okay? So 4 times, 5 times steel. So besides this, if we come to the actual property of the material, then we will come to know that for Young's modulus, as far as concerned with the Young's modulus, for aluminum 70, for steel it is 210, and For graphite epoxy, that is 181. For glass epoxy, that is 38. So the specific if value we are trying to identify, then it is very less as compared to composite material. We'll take one more example, that ultimate strength. Now, if we are taking example of ultimate strength, then what happens in case of ultimate strength? See here. For aluminum, that ultimate tensile strength is near about 275. For steel, it is near about 648. As far as concerned with this graphite epoxy, that is 1500. In case of glass epoxy, that is 1062. Okay. So try to see that in megapascals, if that ultimate tensile strength is tried to measure, then how drastic difference is we are going to observe with reference to aluminum or steel material in case of composite materials. As compared to this aluminum, for glass unidirectional graphite epoxy, that strength is 1500. Is it okay? Means we can observe that 5 times ultimate tensile strength is more in case of graphite epoxy as compared to aluminum, and near about 2.5 times of that of steel. Means if we take example of unidirectional graphite epoxy, that particular material is near about 5 times lesser in weight, but 2.5 times higher in ultimate tensile strength. So how this is useful, that we can take the judgment with that available properties here. Is it okay? So that's why these materials are always preferred in aerospace industries. Okay. So that example is sufficient for the comparison of fibers. So now let us come to the part of classification that we are interested in, because we have to see the comparison. So here we can see that how these different materials are there. For laminated composite material, as far as concerned with this particulate metal matrix composite and short fiber, and then laminates. So how these laminates are there? One lamina. Here you can see that in this figure also it is shown. So you can observe here. So like this is one lamina, this is another lamina. Like this, the laminated structures that are kept on each other. Is it okay? Then we will try to identify here then clad metals. So the cladding or sheathing of one metal with another is done, and that is also one of the part of composite material. Is it okay? So bimetallic strip, that also we will consider as a composite material. Bimetallic strip. Two different metals are there that are joined together in order to have the different applications like bale application, etc. Then we will come to know that how these composites are there. So clad metals, that is also one of the example of that. Is it okay? Then laminated glass, then plastic based laminates, then particulate composites, then non-metallic particles of non-metallic matrix, metallic particles in non-metallic composite materials. Is it okay? So here we can see mechanical behavior of composite material. So materials are isotropic, materials are orthotropic, materials are anisotropic also. Isotropic means the properties of the material remain same in all direction. Orthotropic means the properties of the material in 90-degree direction. But in case of anisotropic, the properties of material doesn't remain constant any two direction also. In all three directions, the properties are different. So here we can observe that basic terminology of laminated fiber reinforced composite materials inside that. The example we have taken here, a lamina with unidirectional fiber. In order to understand the fibers or lamina, So this concept is useful here. You can see the basic building block of the laminate is the lamina. Is it okay? So one lamina, number of such laminas come together in order to form the laminate. Is it okay? So single layer of glass fiber, single layer of carbon fiber, we will call it as a lamina, glass fiber lamina or carbon fiber lamina. If suppose one more layer is given of the epoxy on that, and again one more layer of this carbon fiber or glass fiber is kept on that, then now these two lamina together plus epoxy one lamina, like these three laminas will make this as one laminate. Is it okay? So we should understand the difference between lamina and laminate. Single is lamina. Here one figure is shown at its bottom. We will try to understand with the help of this figure here. You can see what is lamina and what is laminate. Here we can understand here. So see here different. I think you are able to observe on the screen. Just observe your screen, you will come to know that this particular portion we are considering this as a single lamina. Then this is another lamina, second lamina. This is third lamina. This is fourth lamina. Here we can see this as fifth lamina. So these are different laminas, and that all laminas will come together. Suppose all these laminas are there that will come together. When that will be bounded together with the help of any binding material, then whatever the construction get forms, that construction is considered to be a laminate. So that is the difference between lamina and laminate. Is it okay? So try to understand these things. Lamina, what is lamina and what is laminate? Is it okay? Then again, if we try to understand here the, suppose this one continuous type of fiber is embedded inside this one. But this direction, suppose we are considering as the x direction, then this is here at the bottom, this is y direction. Again, this is the x direction. Here we can see this is inclined to this one. So these kind of combinations are generally used in case in order to manufacture the laminate, because in order to have the properties of that material stronger in all directions, this kind of combinations are required, because whatever the whatever the fibers we are using and we are afterwards considering this as lamina, if that is unidirectional, then that specific act along the specific direction strength is large. But for different directions, the it will have different performance. Suppose in transverse direction, here this is the here you can see in this direction, in x direction, like this, these are present. But if suppose in a perpendicular direction, if we measure here, if force is applied for this particular lamina here, then this will be weaker in 90-degree direction, but it will be stronger in that particular specific direction. Is it okay? So like this, here we can see the unbounded view of laminate construction, how that different laminates are constructed with the help of different laminas. Is it okay? So with this, our first chapter, as far as concerned with this introduction to composite materials, yesterday we have finished the definition of composite material, how these two or more than two materials are composed together in order to have the different properties, and that are bounded together at macro level but not at micro level. That part we have studied. Then we have seen the classification of the composite material. Then we have seen the types of composite material. Inside that, first of all, types of matrix material. So polymer matrix, then metal matrix, ceramic reinforcement matrix, and then the reinforcement. In that reinforcement again now we are observing. Then what is fiber composites? So that we have seen by taking the example of glass fiber, carbon fiber, graphite fiber. Is it okay? We have taken the example of graphite fiber, and in that graphite fiber we have seen how the strength of the graphite fiber is larger as compared to this steel or as compared to aluminum. So if we take the example of aluminum, if we take the example of steel, then as compared to steel and aluminum, the ultimate tensile strength of this unidirectional graphite fiber or unidirectional this glass fiber is very very large, that is 2.5 times of that steel. So we consider generally steel is tough material, but it is like this relation. So fiber composites, that part is also seen. Then introduction to laminated composite, that part also we have seen here. Is it okay? So what is meant by this? We can see here the example we have taken about the fibers. Then we are going to the metal matrix composite. So in metal matrix composite, if we see the metals, so here you can see, suppose steel is used, titanium is used, aluminum is used. In that case, we will consider this as metal matrix composite. So this example, this figure already we at the start of this lecture only we started with this figure. Inside this is the metal matrix composite. So whatever the portion shown here is considered to be a metal matrix composite. Is it okay? Then some of the observations which are observed inside this composite material that we try to understand with this, suppose this small figure is in front of us. In case of fiber composites, if we take the example of any fiber, then as the fiber diameter starts to decrease, then fiber strength starts to increase. Means here you can see the inverse proportion. This nature of graph you can see here. As the fiber diameter goes on decreasing, strength of the fiber starts to increase. Means smaller the fiber diameter, larger the fiber strength, that we can observe with this figure. That is the observations which has been found in case of composite materials. Is it okay? So with this as an introductory part of the composite material up till now, we have finished the fundamental terminology of the composites. So here, in order to have the understanding of the different composite materials, here you can see how the utilization of the composite material as the application of the, if we come to part of the application of the composite material, you will come to know that how the different composites are used in different areas. So see here, for electrical and electronics component, the composite materials are used here, you can see. Then for corrosion resistant equipments, that composite materials are used. So already we discussed that composite materials are of different types. If suppose polymer matrix and ceramic matrix are used, then they have good corrosion resistance as compared to metal, because for metal there more than two phases are going to add inside the metal. That phases becomes one kind of obstacle to have the which makes the corrosion inside the metal, because forming more than one phases are always oxidizing to each other. Percentage of oxidation increases and corrosion increases. But in case of this, suppose electrical and electronics, so, the applications of the composite is large, because the flexibility, like yesterday also we discussed about the coefficient of thermal expansion. Is it okay? Alpha is the coefficient of thermal expansion. So we can manufacture any composite material which is in which the coefficient of thermal expansion we can vary as per our requirements. If we want to reduce that, then also we can reduce or require to increase the naturally available materials. With this we can work there. So for electrical and electronic equipments, the use of composite material is increased, has been more application because of that flexibility. Like thermal conductivity, there is one more parameter, that is the electrical conductivity. Is it okay? So as far as concerned with this electrical conductivity for the composite materials, if we want to form any composite material with good electrical conductivity, then this electrical and electronics fields are there where these materials are generally used. Now we know that PCB, that word we always use in case of electrical and electronics. PCB word, maybe it is mobile, maybe it is laptop, maybe it is computer. So wherever microchips are present, all these microchips are generally mounted on the PCBs, and that PCB is also a material, and that is composite material. So in electronics and electrical systems, that kind of composite materials are used. Then consumer products. So in domestic applications, small consumer products are present. Then appliances and business equipments that are also manufactured with this composite materials. The more requirement of the composite materials are in the transportation industries. Whatever the materials are available inside the market presently, more than we can say it as suppose one third, more than one third that is used for the transportation. Transportation purpose, if the composite materials are used, then that means that in aerospace industries that is used, then in marine industries that is used, then in automotive sector that is used. Suppose we take the example of aerospace. Now, recently we were comparing the steel and the graphite fiber epoxy composites, and we came to know that in case of graphite fiber epoxy composites, the weight of the material is 5 times less, but the properties are 2.5 times of more. So that's why how this particular material is suitable for the transportation industries, that we can take with this case study. So more than one third of this available material is used in the transportation. In automotive applications also, generally, if we reduce the weight of the car, then definitely its average increases. Whenever first time the cars were invented, and now whatever the cars available inside the market, presently we are succeeded to reduce the weight of the car by 300 kg. See, so 300 kg, if this weight is saved, then definitely there is contribution of materials inside the weight saving, and that weight saving material is the transportation application, which is the composite materials. Is it okay? Then in marine also, the composite materials are used. So in all these cases, aviation industries, then marine industries, automotive industries, aerospace industries, these composites are used for the transportation purpose. For construction, already we taken the example of the construction, that suppose bar is reinforced inside the concrete. So generally concrete material, we say concrete because this is aggregation of sand, then cement, and then small pebbles, particles, or we can consider as a coarse sand, and all this composed together, inside which the bar of ferrous is added, and when these materials get set, then that becomes a one kind of composite. So RCC pillar or RCC beam, that is an example of composite material. Is it okay? So how this construction or the transportation and construction, these are very important part of the application of the composite material. Then marine industry, corrosion resistance equipment, electrical and electronic equipment, consumer products, application and business equipments, and some others. So these are some of the different applications. So these particular applications are polymer matrix, polymer based composites. Is it okay? So see how these polymer based composites are there. In order to have the survey of these materials, here you can observe the figures. So aircraft or aerospace military, this is the published work in the journal, and this is already for our reference we are kept here for aerospace or military application, then for business equipment application, for construction application, consumer product, origin register, like this. Here you can see how this material in use has been started to increase. Is it okay? So during this classification of the material, we were discussing about the different types of composite materials. Inside that, we taken the reference of particulate composite material. So like this, small particles are there, and that particles are working as ingredients inside this matrix material. So these small particles here you can observe, which are present inside the matrix, and that particular composite, this is considered to be particulate composite. Is it okay? We have taken the example that if ceramic is added inside the matrix, then that becomes particulate ceramic reinforced metal matrix composite. Is it okay? Then here you can see the example of flakes. So small flakes are added here. You can observe here. This is one of the flake. So that flake is added like this. This is another flake. That flake is added. So the flakes are having different shape than the particulates. Particles are smaller in size, but that flakes are present. These are having different shapes. For fiber composites, here you can see that this is one of the fiber. This is another fiber. So like this, these fibers are present here. So end to end, that fibers are added inside the composite material, and like this here you can observe, like this you can see here that fiber composites, how these composites are there. And example of this means short fiber, long fiber, monofilament, like this is an example of the fiber composites. So particulate composites, flakes, fiber composites, here we can see, we can observe the figures of these composite materials. Is it okay? So here the first part of this chapter we have completed, that is what is expected as per the university syllabus. Inside that, what is the definition of composite material? What is the classification of the composite material? Which are the various types of matrix material? What are the various types of reinforcement? And then fiber composites, laminated composites, metal matrix composites, particulate composites. Then coming to the prepegs. So this small part we have to see here. Manufacture of laminated fiber reinforced composite material. Inside that, here you can see the concept of prepegs that we have to study. So prepegs is nothing but pre-impregnated. Is it okay? So here you can see the prepeg tapes. Here you can observe this figure. So you can study here that the fiber and matrix material can be obtained commercially in variety of forms, both individually as well as laminate. Fibers are available individually as a roving, which is in continuous bundles, but not twisted. Suppose fiber is present, that already fiber, if that is impregnated inside the matrix, fiber can, suppose unidirectional fibers are there, then fibers are saturated or coated with resinous materials such as epoxy. Suppose epoxy is the matrix material, and different fibers are there. So carbon fiber is there, glass fiber is there. Then that fibers if suppose already impregnated inside any material in any matrix, suppose epoxy, inside that epoxy, suppose any unwoven or woven, that kind of material is already impregnated, then process is reinforced to pre-impregnation. This is called as pre-impregnated fibers, and that pre-impregnated fibers is nothing but prepegs. Then the process remains only that when such a pre-impregnated fibers are there, that pre-impregnated fibers are generally used to manufacture the direct composite applications. Means what? See, in case of suppose any material we are going to manufacture with the help of this particular pre-impregnated. Here we can see the observe the figure here. One of the case has been shown here. So boron epoxy. So inside this boron and epoxy prepeg steps has been manufactured here. See here, if suppose epoxy already in that form is present and boron is present, then these two layers of boron and epoxy that simultaneously comes up will are wounded on this step. When we unwound them, and these two materials we are combined using by using hot press machine or by using the any manufacturing process. These two materials simultaneously we are doing. So for automation purpose, it becomes very easy, very useful to use this boron epoxy prepeg steps. Is it okay? So pre-impregnated or prepregs, that concept that you can understand from this particular concept of this boron and epoxy pre-impregnated material or prepegs which we consider here. Is it okay? So with this few more applications for next time, we will try to study with this composite material. Anybody any doubt with this? Anybody any doubt?
No, sir.